Okay, yesterday we talked about what it looks like to be concave up, concave down, and how it is different from increasing, decreasing. I'm going to have you put something at the top of your paper, 2 little bullet points. If we're looking for increasing, decreasing, if we're trying to find increasing and decreasing places on a graph, you look at the first derivative. Okay, so you take the first derivative, you set it equal to 0, find your critical numbers, use your test points, figure out whether it's positive or negative, increasing, decreasing, that type of thing. Okay, good? Concave up, concave down, what we're doing in this section, I'll do concave up and concave down. You do the second derivative, which means you do the derivative and then you do the derivative again. Derivative. Most of the ones that I give to you are going to be ones that are power rules that you have to do derivative twice. Okay, I don't think I hardly ever do like where you have to do the quotient rule, but then you have to do the quotient rule again, the second derivative with the quotient rule. I think most of the time when I make you do the second derivative, it's with the power rule stuff. Does that make sense?
First example.
Power rule. What? This one?
Yeah.
So this one is one that you would use the quotient rule on, right? I don't think I give this to you as a homework problem, but I went ahead and gave you what the second derivative looks like. So we took the derivative twice, and it turns out to look like that. That's what it looks like when you condense it. What?
They don't give us one of the derivatives.
Yeah. So I don't think on your homework assignment I gave you anything really super hard to find the derivative of. Okay. So determine the opener intervals upon which it's concave up, concave down. Okay. I gave you the graph. You won't necessarily have the graph. You won't have the graph on your homework assignment, but I gave you the graph so that we can determine what this looks like. Okay. So if you need the steps, do you want me to write steps down? Does that help? Step 1, find the critical numbers by set the second derivative equal to 0. Set the second derivative equal to 0. I ran out of room over there. Find the critical numbers by setting the second derivative equal to 0. Number 2, after you find your critical numbers, make test intervals. Step 3, plug in to find plus minus. Okay, now, when I say plug in to find plus minus, where do you plug into? The derivative. You're plugging into the derivative, into the second derivative. So I'm going to say into second derivative. The only time you plug into the original is at the very end to figure out what the y-coordinate is for your max or min. In this case, it's not going to be a maximum minimum. It's going to be a point of inflection is what it's called. We'll talk about that later. Okay? And then there you go. Step 3 is basically all you have to do, and then you have concave up or concave down. Okay? So they went ahead and gave us the second derivative. So we're going to take this guy that they have right here, that they've graciously done already for us, and we're going to set him equal to 0. And the wonderful thing about that is that the bottom goes away, right? You guys understand why the bottom goes away. Multiply it to the other side, the bottom's gone. 36 x squared plus 1 equals 0. I think there's a typo in this, if I remember right from last year. I think that's supposed to be minus 1. Otherwise, we don't have any critical numbers. So let me check to make sure. I'm pretty sure that's a minus. This is section.
It would cost $150 to what's that thing that's in style with the hair, where it fades into like a lighter color. Ombre? No, not ombre.
X squared minus 1.
Yeah.
Yes, it is a minus 1.
$150.
What's that? How are you guys talking about?
It's because you have
We
long
don't.
hair. Yeah, it's gross. But I'm not paying my hair.
Okay, so it's supposed to be minus 1.
And
I don't know.
balayage and
I don't know.
olives.
Okay, so that is a typo. Fix that typo. There it is. Now what? We have to find the critical numbers. Now what?
That's the thing.
Okay. Now what do we do to solve for x? Go, go, go. What do we do to solve for x?
Just get rid of 36.
Divide by 36, which
No,
really
just
just
cross
makes
it
it go away, right? You could just kind of cross it off. X squared minus 1 equals 0. Add the 1. Plus 1 plus 1. X squared equals 1. Square root. Square root of 1 is what? Plus minus 1. Okay, so we technically have two critical numbers, right?
Wait, where'd you get the minus?
Because the square root of 1 is positive and negative 1.
No. Like,
It's a typo. Fix it.
okay.
Fix it. It's a typo in the original problem. Okay,
Can
plus
I
minus 1.
work your power?
Okay, so
Yeah.
if you have two critical numbers, how many test intervals do you have?
2.
Two critical numbers, you will have
3 boxes.
3 test intervals, 3 chunks. Okay, so our first critical number was -1, our second critical number was +1. So they write our test intervals like that. I usually write them with the commas, right? We've seen that before. Commas versus less thans, x's, that type of thing. Okay, so we need to pick a test value that lives in that interval. What do you want to use for the first interval? -2. Okay, what in the middle? 0. And on the right side, +2.
Wait, we can't use 0, can we?
Yes, we can. Yes, we can.
Plug into that one, right?
Yeah, because we're plugging in the second. Well, even if we plugged into the original, you have the 3 on the bottom there, so it's fine. Okay, so the sign of, and this is another typo that I have in here, this should be the second derivative, so double prime there. We're plugging him into the second derivative, okay? So, 36, -2 squared minus 1 over -2 squared plus 3 to the third power, okay? All right, we don't necessarily care what this number is. We just care if it's positive or negative. So, -2 squared is 4.
They're all positive.
4 minus 1 is 3. 36 times 3, we don't care what it is. It is a positive number. 36 times 3, yeah?
They're all gonna be.
Okay. This is 4. 4 plus 3 is 7. 7 to the third power is just another positive number, so this is positive. Okay?
Yeah.
All right, now we plug 0 in.
So the whole top is
So,
crosses off.
No.
What?
36 times 0 squared
Oh,
minus 1.
Minus 1.
Yeah.
0 minus 1.
Over.
Negative
This way.
36.
0 squared.
-1, 36, negative
This
36,
0 squared minus 1 is a -1 times 36 is a negative on the top, yeah?
Yeah.
On the bottom, we're still going to end up with a positive number, right? So this guy will be negative,
I got you.
right? You see it? Okay. Now, if I plug in +2, really +2 will have the same value as a -2 because when we were plugging in, we were squaring it each time. So +2 and -2 will have the same value. They will both be pluses, right? You see that? Okay, so what does this mean? In conclusion,
Does that mean?
what does this mean?
It means increase, decrease, increase.
But we're not doing increasing, decreasing. We're doing
Cup, cut down, cup.
concave up.
and
This is
concave
caving
down.
upward. This is caving downward. And this is caving upward again. Let's see if that's consistent with the graph. Okay, so the first thing it's doing is caving upward until it gets to this point. Is it caving upward until it gets to that point? Slightly, right? Then it turns around and it's caving downward in between those two. Is that caving downward? Yes, then it turns around and it's caving upward again, right? Does that look like consistent with the graph? Okay, now, I'm going to erase this down here at the bottom. The places where it switches from a concave up to concave down is called a point of inflection.
Yeah.
So let's write that down here. Point of inflection equals switch concavity is what it's called.
POI.
So a POI, you can call it a POI, but for the first time we write it down, we'll call it a point of
Isn't there a
inflection.
board?
So a POI, okay? So this place right here is where it switches concavity. That is at the point what? What's the coordinates?
UTI.
-1 comma something.
I'm a prisoner of
This is where we
UTI.
plugged into the original.
-1 comma something. It also switches concavity here, which is at the point +1 comma something. Now, to find these guys, yes, let's do that. To find these guys, this is where we plug into original. Okay, this is where we plug into the original. Okay, so going to the original function,
Plug in -1 and 1.
6 over -1 squared plus 3.
Right anymore?
That would be approximately 4.
Yeah, 6 over 4,
Yeah.
which is
Original.
6 over 4, which is what?
The oregano formulation.
What's 6 over 4?
1.5.
1.5. So this guy is 1.5. Now if I plug in a +1, +1 squared is going to be the same thing again, right? 1.5. Is that what it has labeled on the graph?
It's not labeled on the graph.
But
It's
it
not labeled on the
looks
graph?
like one
Oh,
It
these
looks like
guys.
it, though.
right here. These points are at the point -1, 1.5 and +1, 1.5.
You know what's really gross?
Those are what are they called?
Yeah.
These are called what?
I have no
I
idea.
always get a
Point
lot
of
of it. too.
inflection.
POI.
Point.
Points of inflection. That's what those guys are. Okay? Good?
Yeah.
Let's go down to the next one. Let's do another one.
Grossly, like, sticky.
Okay? They give me the stuff again. Okay?
What the hell?
This is my original function. Just wait.
Wait,
My
wait,
original function and
So we only have to.
It needs
Why
to
do
be
we have to
heard.
write the POI?
because they're going to ask it later. In this question, technically the only thing they were asking is concave up, concave down. So we were done at that point. But going forward, they're going to ask for POIs also. So I just wanted to practice on that one as well. Good? Okay, so in this one, technically, you were done by saying where the intervals were concave up, concave down. Okay? Let's move on. Let's go to this next one because there's one slight difference. We want to just determine where it's concave up, concave down. Okay? So we technically don't even need to say POIs. Okay? So concave up, concave down. They give us the second derivative here. We set him equal to 0 to start with. The bottom goes away. Agreed? Yes? So 10 times 3x squared plus 4 equals 0.
Divide by 10.
Okay? Divide by 10, so the 10 goes away, right? And then
Subtract.
minus 4, 3x squared equals -4. Divide by 3, x squared is -4/3. And I take the square root. Ruh-roh. The square root of -4/3. You can't take the square root of a negative. So we have no critical numbers. Except, we talked about before, to find critical numbers by setting the first or second derivative equal to 0, okay, depending on what you're trying to find, right? If we're doing increasing, decreasing, it's first derivative, concavity, it's second derivative, but also where you have vertical asymptotes, okay? And how do you find the vertical asymptotes?
Y squared equals x squared equals seven.
Nope.
Equal to
Exponentially
0.
Set the denominator equal to 0, okay? Because we don't want to have those domain errors in there.
Will you write
So-
equal to 0 on the first one?
Oh, equal to 0. Yeah, you're right. Okay. So to find my critical numbers, there's two ways of finding critical numbers. Setting the derivative equal to 0, first or second, whichever one you're trying to find. And then also looking at where the asymptotes occur, okay? So looking at the original function, I set this denominator equal to 0. Can you do this in your head?
Go up. I wasn't done writing. Okay.
Okay.
Plus
I know.
4, x equals positive
X squared equals 4, right? If you add the 4 over, take the square root. So really, plus and minus 2 is where my critical numbers are, okay? All right, now, if you guys remember from the video that I recorded the other day when I was gone, plus and minus 2, those are my critical numbers. So to make those test intervals, we go from -∞ to -2, -2 to 2, +2 to infinity, okay? Because those critical numbers came from vertical asymptotes,
You draw a squiggle.
I usually draw like a little squiggly mark here so that I don't accidentally label those as a point of inflection because there is no physical point at that place,
Blue
right?
panda.
There's no physical point at that place, right? Okay? If you look at the graph, you can see that. There won't be a point of inflection here or here because there is no actual point there, right? Those are vertical asymptotes, okay? Let's pick some test values. -∞ to -2, what do you want to use?
-3.
-3. In the middle, use 0. On the right, use 3. Sure, okay? Where do we plug those into? The second derivative, so this guy right here. All right, so 10, 3, -3 squared plus 4. I can already see what's going to happen on that top one. -3 squared minus 4 to the third power. Okay. On the top, -3 squared is 9. 9 times 3 is 27 plus 4. That's positive times 10 is another positive number. Right? Positive? Is the bottom going to be positive or negative?
Yep.
Positive also, right? We don't care what the number is, so save time. It's going to be positive. By the way, there's a typo here also if you want to fix that one. It's a double prime. Okay? 0 if I plug 0 in. Oh, Let's go ahead and do
40.
3. Well, 3 will be the same as -3, yeah?
Yeah.
Because when you square it, it's going to be the same value. Okay, if I
Negative.
plug 0 in,
Denominator's negative.
blah, 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 0 squared here, that's going to be positive still on the top,
Yeah.
okay?
It's gonna be negative.
But 0 on the bottom, 0 minus 4 is negative, and negative to the third power keeps it negative. So I have a positive number
Good job.
divided by a negative number. So it's negative. Do you guys see that? I went through that really fast. Okay? All right. If you want to go ahead and figure out what the actual value of that is and type the whole thing into your calculator, you can, but we only care if it's positive or negative. Okay? We don't care about anything other than that. All right? Conclusion?
Alright, that example's over. That's the conclusion.
I think we should probably stop there.
Okay, conclusion. What's this?
Brad.
See up.
Concave up, concave down,
CUP.
concave up again. Okay, is that consistent with the graph?
That's crazy. You should look at two.
This is caving up. Shh. This is caving up. This is caving down, yeah?
Jeez, that's crazy. You should.
Okay, now, technically this is a place where it switches concavity. This is a place where it switches concavity, but you be quiet. Shush.
Brooklyn's one who's talking.
But why are those not points of inflection? Hush. Why are they not points of inflection? Because they're asymptotes. So
They
we
never
would
touch.
not label them as POIs. Okay,
We don't
now
need
they're
POIs.
introducing POI to you. A definition of a point of inflection. Yeah? Is place where it switches from concave up to concave down. So it could look like any of these three things.
You have fuzzy on your shirt. No, on your shirt.
Okay? Those are all points of inflection. It changes from concave up to concave down. Good?
Yeah.
Okay?
Yeah.
Let's do this problem and then we'll stop before we do the second derivative test and I'll give you your homework and then you can start working on that. Okay?
Oh.
Yes.
Okay?
Yes.
Sure. Example 3. I do not give you the second derivative of this thing. You can find it.
Ah, shit.
Okay? So, first derivative. What is the first derivative of this thing?
4x 3 minus 12x squared.
4x to the third minus 12x squared. Okay? Second derivative?
12x squared minus 24x.
Okay, 12x squared minus 24x. Now, what do you do with that?
Easy.
This one's easy.
Equal to 0.
Equal to 0. Okay, what do you do with it now?
Ah, shit. Take out an x.
And?
And
And
a
12.
12.
I would take it a 12 and an x. Okay, left over
Oh
is
my goodness.
x minus 2.
x minus 2 equal to 0. Okay, so set both of them equal to 0.
0.
Yeah.
12x equals 0 and divide by 12.
And
X equals
0.
0. That's my first one. Am I going too fast?
No.
No? Okay. X minus 2, set that equal to 0. So x equals 2. So we have two critical numbers. Now, will we have any critical numbers from vertical asymptotes? Look at the original. Is there going to be any vertical asymptotes here?
No.
Why not?
I don't know.
Because there's no
There's no bottom.
denominator.
There's no denominator. There's no nothing that happens, okay? So we only have those two critical numbers, which means our test intervals are what to what?
Negative infinity to 0.
0 is the first one that comes, okay? 0, 2,
2.
2, and
2 to infinity.
2 to infinity. Okay,
There's
so
another typo.
there's another typo, double prime.
Negative 3.
Because I just copy pasted these tables, right?
Oh.
So what number do you want to use?
Negative 3, 1.
I can't believe you did
I would
that.
do negative 1,
I can't believe
Oh,
you did that.
shoot.
right? Why don't we do
That's
negative 1?
plagiarism. You
I was
plagiarized
looking at the other one.
Negative 1, 1, and 3. There you go. Okay, good?
Now
All right,
there's
now
third
plug it
second
into the
derivative.
second derivative. Okay, I'm going to plug it into the second derivative after it's been broken down already. Can we do that?
Yeah,
Sure.
sure.
It doesn't matter if you do this derivative or this derivative. I'm going to leave
That
it broken
one's
down.
easier, the blue one.
You think
Yeah,
so?
The blue one's gonna be easier.
Yeah.
You think it is? Okay,
Well,
then let's, sure.
yeah.
Why not? Why not? Sure. So 12 x squared. I'm going to do negative 1 squared minus 24 times negative 1. Okay? So negative 1 squared is 1. This would be 12 plus 24, which is, we don't care,
Positive.
positive, right?
Yeah.
Okay, now I plug a positive 1 in. 12 times positive 1 squared minus 24 times positive 1.
That's gonna be a negative.
This is going to be 12 minus 24, so negative. Okay?
What's
3, 12 times 3 squared minus 24 times 3. That's what I don't know. 12 times 9 is 108.
And choose.
Minus 24 times 3, 2, carry the 1, 72. Okay? We don't care what that number is, it's positive. Okay? Now, most of the time it's going to switch concave up, concave down, but don't assume that. Okay? Don't assume that it's going to alternate. All right? So, concave up, concave down, concave up. Okay?
Wow, that's deep.
So if we list everything out, let's list it out like we're supposed to. Concave up, concave down. And the other thing that we need to list is what?
POI.
The POI. Okay? Concave up, there are two places, from negative infinity to 0, and also from 2 to infinity.
POI is point of
Okay.
interest.
Concave down is 0, 2. Okay?
That's
Now,
interest.
are those POIs, those two places?
That's what I said.
Are those two places POIs? Or are they vertical asymptotes? Are those two things POIs?
Yeah.
Those two places, okay? So we have two of them, and they are at what comma something?
0, 0, 2,
0 comma
16.
something and 2 comma something, right?
Negative
Because that's
16.
these numbers. Do you guys see where those numbers come from? At 0 comma something and at 2 comma something, okay? Where do you find the somethings?
You plug in the x's
Where?
in the OG equation.
In the original
He said
equation?
OG, dude.
Yeah.
Okay.
Well,
Oh, 0
Stack
to the
halves.
4th
Yeah.
power minus 4 times 0
Dollar
to the
Tree
3rd
Hex
power.
set.
That is
Dollar Tree Hex
Okay,
set.
you got water.
0, 0. Okay, now plug 2
You got
in.
water.
2 to the 4th power is what?
8 times 2.
16 minus
Down, Jamal.
2 to the 3rd power is 8. 4 times 8 is 32. What's 16 minus 32?
Say negative 16.
Okay, is that where it's at on the graph?
You sure?
No.
Yep, looks right. Nope, looks like it's at negative 27. Wait, never mind.
Negative
No, I
16
know.
is right above
That's
negative
right.
18. Okay,
I was like,
those are my 2 points of inflection. Okay, it is on the graph, it's going concave up from here to here. Is that what we labeled it as? Then it's concave downing, then it's concave upping. Right? Okay, good?
Put her in reverse, Terry.
All right, there you go. All done. We'll do second derivative test tomorrow. I'm going to give you your homework assignment, and it looks like I don't have it on here. I don't have it on here. Okay?